Hello, this is question 18 on your June 2022 paper 2 from AQA, and you have an object O of mass m kilograms is hanging from a ceiling by two light inextensible inelastic strings of different lengths. Shortest string length is 0.8, so this one is 0.8 and is fixed to the ceiling at 8, and the longest string is 1.2, so this is 1.2. The object hangs 0.6 meters below the ceiling, and so that the tension in the shortest string is over 30% more than the tension in the longer string. Tensions are going to be different, not like in other questions, because the strings are different. Yeah, it's not like when the questions are, when those questions that you have a bead and the same string going through both. So this is the TA, let's call it TA, and I'm going to call this TB, and I have to see that TA is 30%, over 30% more than this TB. Is in equilibrium, that means I can use forces. Let me draw the weight. This is the weight. If I consider vertical direction to resolve forces, I have mg in my equation, and I don't want that. But if I consider horizontal direction, I only have the component of T8 and the component of TB in the horizontal direction, which means I can find a relation between them two. So let's go to solve horizontally. That means that TB, let's going to call this beta, for example, this angle. I have that TB cos beta, because it's adjacent, is going to be equal to, and I'm going to do the same with TA. So I have a component here, horizontal component. I'm going to call this alpha. This is TA cos alpha, yeah, and this was TB cos beta. So this is going to be equal to TA cos alpha, and I have enough information to find alpha and beta. So if you look at this triangle and on this triangle, I'm going to find the angle. So let's going to look at the A one. So this is A, this is O, and I call this alpha. This is 0.8, and I know this is 0.6. Yeah, so this length is this length. I'm looking at this right angle triangle. Yeah. So I know this is 0.8, this is 0.6. That means if I need cos alpha, it's going to be the adjacent divided by hypotenuse. I don't have the adjacent, but I can use Pythagoras, or I can do cos minus 1. I think I like more to find the exact value, just to keep it until the end. But you could do sine minus 1 and find then cos. So if I use Pythagoras, this missing side is going to be square root of 0.8 squared minus 0.6 squared. And this is root 7 divided by 5. Which means cos alpha is going to be adjacent, so root 7 divided by 5 divided by hypotenuse, which is 0.8, yeah? And this is root 7 divided by 4. This is cos alpha. As I say, you can do sine minus 1 of 0.6 divided by 0.8, and then do cos of that and just get the decimals. I think this is slightly better. And then I look at the other triangle, the right one, the one with B. Sorry, this is a B, and this is O. So I'm looking now at this triangle here. Yeah, and I know the hypotenuse is 1.2, and this is 0.6. So 1.2, 0.6. I have beta, and I want cos beta. So cos beta will be, again, adjacent is going to be square root, using Pythagoras, 1.2 squared minus 0.6 squared. This is 3 root 3 divided by 5, which means cos is going to be adjacent divided by hypotenuse. 3 root 3 divided by 4. And then if I go back to my connection between TA and TB and substitute cos beta by this one and cos alpha by this one, I have, so I'm coming back here. This equation is going to look like TB cos beta is 3 root 3 divided by 4 is TA cos alpha root 7 divided by 4, which means TA, that is the one that is 40% more than the other, TA is this value here divided by this value here. When you do that, you have 2 root 21 divided by 7 of TB. And this is 1.309 TB with 3 decimal places. And this is slightly more than 30% more than this one, yeah, than this one. So TA is 30%, over 30% more than 3 TB. Yep. And then next part says the tension in the longer string, so TB is 2G newtons, and we need to find the value of M. So if you look at the particle, to find M, we need to work in the vertical direction, right? So to work in the vertical direction, we can resolve forces in the vertical direction. So pointing down, I have mg. Pointing down, I have mg. And pointing up, I have the components in the vertical direction of TB and TA. It's going to be a bit messy if I do it here, but the vertical component of TB is going to be TB times sine, because it's the opposite to the angle. So TB sine beta, and the vertical component of TA is going to be TA sine alpha. So I have TB sine beta plus TA sine alpha. I have TB, and I know the connection between TA and TB. So if we want to be completely accurate, we can use this number here, yeah? If not, we can use the rounded one, that I think that's what they use in the market scheme, but I would use this one, 2 root 21 divided by 7, 2 root 21 divided by 7 times TG, yeah? So 4/7 root 21 G. So we know both tensions, and we know sine beta and sine alpha from these triangles, yeah, or from this one. So sine alpha is opposite divided by hypotenuse. So 0.6 divided by 0.8, which is 3/4. And sine beta from this one is 0.6 divided by 1.2, which is 1/2. Yeah. So I have that mg is TB, which is 2g, sine beta we say is 1/2, so times 1/2, plus TA, that's that big number, g times sine alpha, which is 3/4 times 3/4. We can cancel g and g, and we have that m is 1 plus root 21, 3 root 21 divided by 7. And if we do this with the calculator, you have 2.964 kilograms to 3 decimal places. The answer in the market scheme is 3, and they accept this one because this is in fact more accurate. And if we round to what? To one significant figure, we will get 3. Or even to 1 decimal place, yeah? And that's all with this question. So that's the math.